So that's the software, model sim software. It's for modeling. What's important to understand, what are we doing? If we want to model properly, we have two programs. One is the one we are testing, another is so-called test bench testing programs. You probably learned this in electronic devices and basics of electronics, that you can analyze the transistor as an active 4-pole, I think it's called like that, when you don't care what's inside, but you just read some parameters from the outside and measure the curves. In this case, it's the same. The test bench doesn't know what is inside the testing program. You just connect the inputs to the inputs of a testing program to the outputs of a test bench, and read the outputs of a test program to the inputs of the test bench. So this means that you just apply certain signals to the inputs and read the output. How does it work? So it's pretty easy to manipulate this way. All right. So we'll start from writing simple program. So any simple program begins with library declaration, as we'll use this rule that input and output is always either std logic or std logic vector, like in real life, to get as maximally close as we can to the FPGA. Because in real life FPGA, we have some such things as routing, and routing, there is some UCF file called for routing directly outputs of our subprograms directly to the board outputs. So we are going to use library IEEE, and we're going to use std logic 1164 all. Alright, so here's our library. Then we always have to describe entity. So our entity is our program name. So entity, well, program, for example. Entity program is, and when we specify the port. So this is the direct inputs and outputs. So for the beginning, what we're going to do, we're going to use to do simple or element. So we have 2 bits as an inputs, and we can calculate what is logical or performed between these operators. So we have A as input. So A, and the type is std logic. B is also std logic, and for example Y is our output, also std logic. Note that in VHDL there is no semicolon after the last statement before the brackets. That's pretty hard to remember. And entity declaration always ends with and entity name. So in the program, now we can call it, for example, program 1. Now we have to specify the architecture. Architecture, and then each architecture must have its name. Architecture, for example, behavioral, of, and then we assign architecture to our entity of program 1. Is, and here we can have certain declaration of signals if we're going to use, but we don't have any signals. So and we write begin. And after the begin, it's the only function which we're going to perform is y is assigned to A or B. That's all. And end. And after end, we run it into behavior. All right, that's all. That's all the program. You see now it has a question mark. So we press compile and compile selected. All right, let's see some where are the mistakes? Let's see some errors. Moment is yes, for sure. IEEE. All right, compile of program was successful. Great. Now we're going to write test bench to test whenever it works. Okay. So in the test bench. Okay. Then we're going to use the same library. Now, if we're going to use test bench to a program, we have to name it as always. So it also must have entity, but we'll call it test bench of our program 1. And test bench doesn't have physical inputs and outputs. So is and we leave it empty. And now we have architecture. We can call it however we like. We can call it the same, also behavioral, doesn't matter. It's also given name, whichever you choose. Behavioral of, and once again you have to assign this architecture to your entity. And this part is very important. Now in this case we have to add we have to somehow perform the connection between our test bench and the actual program. So in VHDL it's done like that. We add our program as a component to our architecture. So it's done like that. We write the component, system mode component, and then write the component name to know how to connect. The component name must correspond to this one, program 1. And then we write as always is, and now for that part we just copy the whole port assignment. It has to be completely the same. All right, and that's basically it. The important part that when we write end, we don't write end program 1, we write end component. That's the part we have to remember. All right, we have added component when we write the begin. Before begin. Also, if we want to connect to A, B, and Y signals, we must have our own signals in our test bench to perform that connection. We have to we must have something to connect to these ones. So these are somehow like our in real programming variables of one program, and we now must have variables of this one program only. This is not variables, this is signals in this type, but still it's internal signals of test bench, and these ones are signals of our program which we are going to test. So we have to define them. So write system word signal A, B, and Y, and all signals are the same type std logic. Right, now begin. And now the last part we have to do is we must write so-called port map. Now we have the signals of program 1, we have the signals of our test bench. Now we have connect this A to this A, this B to this B, and this Y to this Y. So it's done by port map. First of all, you have to name the port mapping. You have to specify the marker. It can be anything you like. duty 1, my assign anything you like. So, well, all right, duty 1. So, duty 1 assignment, right? And then you have to write what component I'm going to assign. So, the component is program 1. And then we start with the port map. Okay. And now we assign A. A should be assigned to, also assignment to other side, to A. So internal, external, the same with B. And this time it's not semicolon but comma separated. And of course, no comma after the last one. We have to provide certain values. We have to write something. So we have to write certain values in this case. So now we'll try to write something like process, like a process to assigning values one by one. All right. Let's and as we'll apply these values in sequence, we have to use a sequential logic. So we'll assign values one by one. So we are going to use sequential logic. We have to use process. You can name process as you wish. Before the word system or process, you can write the name of a process. So we're going to use something like input output generator. And then we write system or process. And then begin. For sure, we can use declarations, but we don't need any declarations in this process. So first of all, we assign A with certain value. A is equal. First, let's begin from the beginning. 0, 0. B is the same. Yes. So first of all, both zeros. Now, to see the result, we have to add certain wait time. We can use a special simulation statement. Wait for 50 nanoseconds, for example. All right, then 0, 1, 1, 0, and 1, 1. So all 4 possible values are separated by 50 nanoseconds. All right, what we're going to do next, we're going to use some special AND statement to distinguish the end of modeling. When we press run all, it will cause a failure and stop modeling. And in this part, we write just end of the process. So, process, and once again, end the whole program and the whole architecture. All right, let's try to see how does it look like. Compile selected. Somewhere is an error. Let's see. What's wrong? Ah, sorry. Compiling is successful. Now, if we want to simulate, to start the simulation, what we're going to do? First of all, we go to the library tab, select work. Let's see, one moment. right, go to library and select our program 1 we just built, and press right click and simulate. Now we'll wait for a few minutes, for a few seconds. Here the view changes. Very well. So now we have certain objects and the wave, and we add objects in here. All right, and now we press run all. Moment. Simulation. Something wrong. Right, and here we go. Somewhat with the software, somewhere, so we have some problem. I will reopen it. And simulate. Also, once again, okay, now it works. All right. So if we'll start from the beginning, we have our two programs, one and another one. We go to library, work, and when we choose what we want to simulate, we simulate not the program, but we always simulate the test bench, which shows which connects to a program and shows the results. So we press right button, right click, simulate. All right, now something changes in our screens. We choose wave. If wave is not displayed, we press view, and here we have to select wave. Here we have an object, our free signals, which are connected directly to our simulational program. We drag and drop them to our wave window, and then we have to press run all. It starts simulation, and you could read here that it was modeling until the end of modeling. So I caused, and by this line, end of modeling, I caused the severity failure, which caused in stopping of modeling. So the modeling was automatically stopped at that place which we desire to stop the modeling. All right, and now we can zoom it, and we see that first of all, 0, 0, and the answer of OR is 0. 0, 1 is 1. 1, 0 is 1. 1, 1 is 1. For example, if we want to change OR into AND element, so it's easy to do. We just go to project, or directly here, go to program, go to program, and change from here to, for example, AND. All right, save. In this place, we have question mark. We press compile, compile selected, and in order to simulate the view, we have simulate and press restart with simulation. We restart with simulation, then press run all once again, and here we have in wave completely different results. 0, 0, it's 0, 0, 1 is 0, 1, 0 is 0, and 1, 1 is 1. That's all, and simulate and end simulation. All right, questions?
I tried doing the same as you did, but I'm getting an error loading design.
So somewhere you probably made a mistake.
It compiled correctly everything, but it doesn't simulate. It says that I should go to the website and update my version, even though it's the newest one.
I think that usually certain problems are when you have a very long path. This software doesn't like long paths at all. It likes when the path is short, directly to C drive somewhere.
Okay, I'll check.
All right, this part. Now, your task, what you'll do by yourselves. So we add new file. We'll call it add, for example. And in this file, what you're going to do? In this file, you're going to use two libraries. With program add, and here it's program add. And here we are going to work with ST logic vectors of identify. And all the vectors will be 8 bits. And the idea will be to arithmetically add those two. But to add, you'll have to convert, or in this case, cast to unsigned. And then cast back to.
Should it be down 2? But because it's now down RO.
Down 2 for sure, for sure. It has to be down 2, definitely. Just something like that. Somewhere. Let's see. Yeah. For sure. If here is program add, here is program add. So here it also must be program add. That's definitely. All right. So I'll add these source codes to the Moodle today. So your task for your today work is to model this program by yourself. So that's all from the theoretical part for today. So prior to next meeting, every one of you should have modeled this one and everything should work fine. If you have any questions, just write me an email. Also, don't forget that each lecturer in the department has so-called duty hours. So we can write me an email and we could meet during the duty hours via Zoom and discuss it privately if you have any questions. So don't hesitate to use it. So,
sir, I sent you an email yesterday about a subject with a similar name, Programmable Microsystems.
Yes, I discussed already it with department, the head of the department. It's strange that I don't see you and you don't see the subject in your schedule. Is that a problem, yeah? As I remember.
Yes, yeah, I see the subject in my manual system, but I don't see it on the schedule at all. It has no lecture, and even when I check the subject itself.
Yes, I'm going to meet today the head of the department, and we're going to discuss the problem. I think we'll solve it out somehow. Don't worry about that.
Okay, thank you. So I'll wait for the replied email.
All right, now I've got everything yesterday. It was, I think, in the evening somehow. All right, so that's all for today. I'll add and explain the task what you have to do to next time today to Moodle. So if you have any questions, just ask or write me an email and we'll discuss.
Professor, what are your working times?
I don't remember now in a schedule, but you just can write me an email and we'll arrange it any possible which fits me and you. That's not such a problem. Just write an email and we can agree and meet, because if no, I'm not just waiting for with active Zoom for someone to call me. We can shift with time and arrange the time which fits you. All right, so that's all for today, and so see you on Wednesday. Don't forget, you all have to be prepared up to that time. All right, so thank you for attention.